there, so we should be done quickly. No, just kidding. Let me start by showing you a picture. A bit slightly darker here, perhaps. Yeah, we're showing you a picture that is possibly the deepest view of the universe ever taken. What do I mean by that? We're looking as far into the universe as we can. Some of you may have heard of a space telescope called the James Webb Space Telescope. I see some nods, yes. This is a picture taken with the James Webb Space Telescope. And this is what's called a galaxy cluster. Lots of galaxies like the Milky Way and bigger, some smaller in the foreground. And then behind that galaxy cluster there are many more galaxies. But because there is a massive group of galaxies in the foreground, the galaxies in the background start to look like those little streaks. Just like you would have if you looked through a glass lens. This is called gravitational lensing. So really the most distant objects that we're looking at here are those little streaks that are all red. A very deep image, the best image of the far universe that we have today, and James Webb has only been around for a few years, so there's a lot more coming out of it. This was the best image before James Webb. This was taken with the Hubble Space Telescope. And in order to get this picture, the Hubble Space Telescope works like your photo camera. You say, I want to point in this direction, I want to open my lens for so long, and then you open the lens, you collect all of the light, and when you close the lens again, that's what came out. Do you know how long it took them to take this picture? The Hubble Space Telescope is a telescope with a diameter of 2.40 meters. They opened the lens for 23 hours. This came out. There's about 5,000 galaxies in there. No stars, no individual stars, only galaxies, like the Milky Way, and actually much different. So at the moment we have a fantastic suite of instrumentation out on Earth and in the universe. And I'm going to show you that briefly what we have right now. These are the best of the best, not just any single telescope like at Macquarie Uni. We have a telescope. Doesn't show on that, it's too small. On the ground, we will soon have a new facility called Rubin, the Rubin Observatory, which is a mirror telescope with a diameter of 8 meters. And we'll take a picture of the entire night sky every 3 days. So we're getting a movie of the night sky, pretty much. We're going to look for objects that go bang in the sky, that change color, that change brightness, and all that kind of stuff. Variable objects. The most advanced radio telescopes include the Square Kilometre Array, part of which is being built in Western Australia, the other part in Southern Africa. The ALMA array, very high up in the Atacama Desert in Chile, which is millimeter, that's all radio. The whole thing from left to right is wavelength. We can see visible light from the ground, but anything else pretty much is not visible from the ground. The Hubble I talked about is at an altitude of about 500 kilometers, that's what we call low Earth orbit. Looks at visible light. You may have heard of Webb. Webb is about 1 million kilometers away from us, beyond the moon's orbit. And there's a couple of other satellites that are about, Euclid has been launched, Roman is about to be launched, and then we have an X-ray satellite here, Chandra, and Fermi is gamma rays. So there's a whole lot of fantastic facilities out there that we use as astronomers. I guess I've confused you already, so let's get back to basics and start from the very start. Yes?
Where's the first one, the big one, the native one?
The first one, the big one.
Rubin.
Rubin is currently still under construction in Chile. Chile is one of the best sites for ground-based astronomy, optical and infrared astronomy in the world. Includes Chile, Hawaii, and actually a new site in China where I visited in the last week of December. An absolutely amazing place, not easy to get to. And I got altitude sickness, which was a problem. It was quite nasty, but anyway, we sorted. And we had 2 punctures at the same time as well, so it was all fun and games. But a fantastic site as well. So those are the best sites in the world. In Australia, we have some professional observatories, including in New South Wales. They're not as good, let me say that. Anyway, let's go back to basics. And I'm going to start in San Francisco. It doesn't really matter, because as soon as we take a few steps, we're away from the Earth. But we're starting in San Francisco. And we're starting with a small picture that's 10 centimeters on the side. And you remember from my title slide, we're going in 26 steps, and I'm starting at step -1. That's in essence that little exponent up there. If you're not mathematically inclined, that's perfectly fine. That number is the step number. right? And we're going 26 steps, so up to step 25. 10 centimeters on the side. Every single time I show a picture like this, it's 10 times bigger on both sides, right? So 10 centimeters, that was just to set the scene. We're now going to 1 square meter, 1 meter by 1 meter. Those are the sizes that we are familiar with, you and I, but 1 square meter. I'm an astronomer, so that's an approximation, okay? In astronomy, we approximate everything. So people, 1 square meter. Objects in the sky, they're round. We call that spherical cows. Right? Anything and everything is approximated by something round, something spherical, even if it's not. Anyway, 1 square meter, light takes about 3 nanoseconds to cross this picture. A nanosecond is 1 billionth of a second. So very, very short. 10 times bigger again, step number 1. We have a park here. Now this is Golden Gate Park, a pond in Golden Gate Park. 10 times bigger again. 100 meters on the side, that's the Japanese tea garden in Golden Gate Park. 100 meters, that's slightly bigger than the Maritime Museum, I would say. And that's the size that we're familiar with Central Sydney, the Opera House, about 100 meters. And it's also similar to the size of the largest living things on Earth. You can see here the largest trees. General Sherman here is about 100 meters high. I visited with my wife there, and it was quite funny. You can stand and you can just walk through the tree. This is in California. The largest animals are the blue whales. They're about 30 meters long. So these are the size scales that we're still familiar with. Step 3, 1 kilometer on the side. Now we see the center here of Golden Gate Park in San Francisco. That's of course also the size of our beautiful harbor right here. That's the size of 1 kilometer on the side. Human sizes that we're still familiar with. Step 4. We're going to slow down at some point, don't worry. But we're going to the universe first. 10 kilometers on the side, central San Francisco. Step 5, 100 kilometers on the side. You see the Northern California here, San Francisco Bay Area. 1,000 kilometers on the side. That's called a megameter, by the way. We see California. And now it's time to go to space. So let's do that. And it's going to be a bit loud.
T-minus 90 seconds and counting. All systems are go. We're about 90 seconds from the launch of Space Shuttle Discovery. T-minus 60 seconds and counting. We are transferring to orbiter internal power at this time. Discovery is now running off its 3 onboard fuel cells. Coming up on a go for auto sequence start. And we have a go for auto sequence start. Discovery's onboard computers have primary control of all the vehicle's critical functions. T-minus 17 seconds and counting. 15, 12, 11, 10, 9, 8, 7, 6, start, 2, 1, booster ignition, and liftoff of the Space Shuttle Discovery. Returning to the space station payload running for future mission.
Alright, that was loud, but now we're in space, so welcome to space. I did this talk in China recently for a whole bunch of school kids, and I showed them Long March 5, and they were all very excited when we got to space and started clapping and all that. Anyway, we're now yet another factor of 10 bigger. 10 to the power 7, step number 7 on the side, and now we're not looking at a square picture anymore, we have 3-dimensional depth as well. The size of the picture are 6,400 kilometers behind the middle of the picture, because the Earth is round, right? So that's what we're seeing here. That was there. The Earth, of course, is a beautiful planet. This is an animation made of real pictures taken with a whole bunch of weather satellites. You can see how beautiful the planet is, and so we have to be very careful of our fragile planet and its nature and its atmosphere. So anyway, I always like to look at the planet, and later on, in the next few slides from now, we'll have a look at planet Earth from the edge of our solar system and see how tiny it actually is. Now, around this area, so that was just 10 to the power 7 meters on the side. We go one step bigger, we are 10 to the power 8 meters on the side, and all there is Earth and empty space. In that empty space, the only things that are there are satellites that are man-made. And there's a lot of them. In 1957, Sputnik was launched, and over the years, the number of satellites in what we call low Earth orbit, but also in geostationary orbit, which is a bit further out, has multiplied significantly. These are individual satellites. All those ones close to Earth are in low Earth orbit, 300 to 500 kilometers high, and these geostationary satellites are about 36,000 kilometers from Earth. So that's until 2015. In the last few years, this has shot up by factors of multiple because of Elon Musk and Starlink. Starlink has been terrible for astronomy because now there are so many of those satellites that professional astronomers see them routinely in their images, their spectra, and their observations. So it's actually quite bad for science, but that's what it is. Now, in low Earth orbit, we also find the International Space Station. And you can see how many satellites there are in low Earth orbit. And so we have to be very careful that we don't run into some bit of debris or whatever, right? But that does happen occasionally. And so here we have altitude, so how high we are above the Earth. Airlines 10 kilometers, International Space Station 354 kilometers, and the Hubble Space Telescope here at 600. And there was a collision in 2007 between a Russian satellite and a US satellite that caused a lot of damage. And it's very easy to get damaged by flying debris in orbit, and that could be devastating. You can see that here. This is just a tiny little bit of debris that has hit the outside of the International Space Station. At least you can see what the thickness of the International Space Station is there. This here is a bit of the robot arm that's actually been damaged, and that could be devastating. So I have a brief video that tells you a little bit more about the events that happened. There was this collision between two satellites, and then China later decided to test out a laser weapon, and that caused a lot more debris in Earth orbit.
Until 2007, experts tracked around 12,000 large pieces of junk. But since then, two events have caused the situation to degenerate. One involved Cosmos 2251, a Russian satellite in low Earth orbit that suddenly malfunctioned. The Russians could no longer communicate with it and were unable to deorbit it to Earth. In a perpendicular trajectory at the same altitude, a brand new American satellite called Iridium 33 was in orbit.